example 4, I think it might have been read example 3, but it should be example 4. Sampling distributions of the sample variances using StatCrunch. 3 randomly selected children are surveyed. The ages of the children are 2, 7, and 9. Assume that samples of size n equals 2 are randomly selected with replacement from the population of 2, 7, and 9. Listed below are the 9 different samples. In part A, we want to be able to find the population variance. So we're going to go to StatCrunch. We're going to enter the numbers 2, 7, and 9 in a new column. We're going to click Stat in the top menu. We're going to select Summary Stats and then Column, and then select the column you just created with 2, 7, 9. And since we are looking for population variance, we're going to select the unadjusted variance from the Statistics menu and then click Compute. So let's open up StatCrunch. So we'll just call this population, since it's going to be our population variance. And then we're going to put in the numbers 2, 7, and then 9. And so now we're going to come over here and select Stat. We're going to go to Summary Stats and then select Columns. And we're going to select the column that we have just made, which is population. And then we want to scroll down to where we can find the unadjusted variance, because that represents the population variance. And let's select Compute. So I'm going to go ahead and copy this for our population variance. And so we get the value of 8.66666667. So if we round it to 3 decimal places, we would say that the population variance is 8.667. Okay, now find the variance of each of the 9 samples and then summarize the sampling distribution of the variances in the format of a table representing the probability distribution. So we're going to go ahead and open up StatCrunch. Okay, and so we know that we're going to have 2 numbers. So we're going to call the first column x1. We're going to call the next column x2. So in the first sample we have 2, 2. So we're going to leave this as 2, and then this one's going to be 2. The next one is 2, 7. So 2 and then 7. The next one is 2 and then 9 and then 7 and then 2, 7, 7, 7, and then 9, 9, 2, 9, 7, then 9, and then 9, and then 9. And again, we got those from those numbers up here. Okay, so now that we've done that, now we're going to follow the following instructions. Now, the samples are in rows. So we're going to click Stat at the top of the menu, and then we're going to select Summary Stats and then Rows, and then we're going to select 2 columns that we just made, x1 and x2. And since we are looking for sample variances for each sample, select Variance from the Statistics menu and then click Compute. So let's go ahead and do that. So we're going to go to Stat, we're going to go to Summary Stats, but now we want to select rows because we want to find the sample of each row. And then we're going to select both x1 and then x2. So we want to hold the control button down. And now we want the sample variance, so we're going to select the variance there. Okay. And then I'm going to go ahead and then select Compute. So here is my table. Okay, so we have the first one represents 0. The second one has a variance of 12.5. The third one is 24.5, all the way down to the following. Now, here it says since the question is asking you to enter your sample variances in ascending order, which is least to greatest, you want to select the arrow to make sure they are in ascending order. So currently, right now, this is what our table looks like, and this is not in ascending order. So if we take a look at our StatCrunch, this is what it looks like. And we want this to be in ascending order. So we need to click on this arrow right here. And when we click on that arrow once, now it puts it in ascending order. for the variances, 0, 0, 0, 2, 2, 12.5, 12.5, 24.5, 24.5. And if you look here, that's exactly what I've copied in there. Okay, so therefore now we're going to use this table to then determine our variances and what our probability is. So let's first take a look at the first one. Okay, the first one represents a variance of 0. Oops. So how many do we have of those? Well, out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, we have 1, 2, 3. So that tells us that we have 3 out of 9, which reduces to 1/3. Next, we have 2. So how many do we have of those? 1, 2. So that's 1/9 plus 1/9, which equals 2/9. Next, we have 12.5, and we have 2 of those. So the sample variance of 12.5, we have 1/9 plus 1/9, which also gives us 2/9. And then we have 24.5 and 24.5. So therefore that variance represents 24.5, and since there's 2 of them, 1/9 plus 1/9 equals 2/9. And so therefore there is our table. Now we want to find the mean of the sampling distribution of the sample variance. The mean of the sample variances is the sum of the 9 sample variances divided by the number of samples. So in order to do this, we're going to first select options in the window on the row statistics table. And then we're going to select edit. And then we're going to check the box store in data table. So let's go ahead and do that. And then we're going to create a new column called row variance. So over here, we're going to select the options, right? And then it says to select edit. So we're going to select edit. Okay, and then you see down here in the output it says to store in a table. So we're going to select store in a table. And then you're going to select compute. Okay, so here you can see that at the top, StatCrunch has created a new column called row variance because now it's stored it in the table. So now we're going to select summary stats and then columns and then select row variance and then select mean to find the mean and then click compute. So now we're going to go to stat, summary stat, select column, and the column that we want to select is the new one that was just created, which is the row variance, and we want to find the mean of that. And so therefore now we're going to select compute. Now let's take a look at that mean. So we found the mean, and you can see that we get the following rounded to 3 decimal places. We get 8.667. And so therefore, this is exactly what we've done to get that mean of 8.667. Now, based on the preceding results, is the sample variance an unbiased estimator of the population variance? Why or why not? Now, if the mean of the sample variances is equal to the population variance, then the sample variances target the population variance. Compare the values of the population variance and the mean of the sample variances to determine if the sample variances target the value of the population variance. And therefore, if the sample variances target the population variance, then the sample variances are unbiased estimators. If the sample variances do not target the population variance, then the sample variances are biased estimators. A biased estimator systematically underestimates or overestimates the parameter. Unbiased sample statistics make good estimators, and biased sample statistics do not make good estimators. Since the sample variance targets the population variance, therefore we would say as such, the sample variance is an unbiased estimator of the population variance.